Hello and welcome back. This is Joe Strout, and this is another episode of the Base Defender live coding project. So let's get right into it. I've already mounted the disk that we've been working on for the last couple of episodes. Let's just run main and see where we left off. Okay, so you might have noticed that several of the little invaders got stuck on corners of the map, and that's the last thing that we noticed at the end of the previous episode. Let's watch it again. Sometimes they do pretty well, but sometimes they just get caught up on a corner. So we're going to fix that first. Then we'll take away this red gradient display so that we can see the intended background. And then finally, well, actually, that won't take very long. So most of the episode will be spent on starting the economy of the game. So we'll have some kind of currency that builds up. For now, I guess just whenever one of the little invading tanks is destroyed, you'll get a little bit of money, and then you can spend that money on buying towers or upgrading your castle. So let's see how far we can get in that today. So first, on the tanks getting caught up, here's my thinking. And I'm gonna pause it just like this. The tanks always check the neighboring cells to see if it's blocked or not, and then they advance in that direction. And the problem is, when they're going diagonally, they can get caught up on the corner of the tank getting caught up on a corner of a cell. Even though the cell that's out in front of them is clear, there's kind of this neighboring cell that's not clear. Now, if they only traveled in orthogonal directions, up, down, left, and right, they wouldn't get caught. So what I'm going to have them do is, whenever they're stuck, their speed drops to 0. That's already working. That's why they stop here. But when their speed is 0, I'm going to have them only check the orthogonal directions. So when they hit something like this, they'll turn, they'll go orthogonally, and then their speed will increase. And I think that that'll get them unstuck. Let's give it a try. So that would be in enemies.ms. Okay. Here's the enemy speed. It defaults to 4, but when they hit something, let's see, here's a check collisions call. And when their position overlaps something, or if it overlaps the wall, that's really what's going on in this case. Self.hit wall. We set the speed to 0, and we move them back 3 pixels. So when they don't hit something, their speed gradually increases up to the base enemy speed, which we saw above was 4. So we can count on the speed doing its thing. It's the check collisions method that we need to consider. And it's really overlaps wall that we're concerned about. Overlaps wall is where? Where is overlaps wall? Hit wall. Okay. Grid.overlaps wall. Oh, that's a method on the grid class. Okay. So let's just go take a look at it. I think it's going to need a new parameter. So it's going to need edit grid. Okay. Overlaps wall. Okay, so this takes a spriter points and no, I'm sorry. The overlaps wall function is fine. That's not the problem. The problem isn't detecting the hit. The problem is in choosing a direction to go, which is this. Check the nearby points and face the closest one. And right now, we're checking all combinations of these differences in x and these differences in y, except where they're both 0. So, we want to say if speed is less than, let's say 2, and and it's not orthogonal. So what does it mean when it's not orthogonal? It means neither the dx nor the dy is equal to 0. So how can we say that more simply? Yeah, if dx is not equal to 0 and dy is not equal to 0, and continue. So when this is true, that neither of them is equal to 0, that means we're moving diagonally. So if our speed is low and we're moving diagonally, or we're considering a diagonal direction, then continue. Just don't consider that direction. I think that'll do it. Let's see. Run main. We should do a reset just to be sure everything is clean. Well, it might help if I said self.speed instead of oops, line 28. Yeah, self.speed. Okay. Hey, look at that. They hit the corner, and then they turn and they bump themselves right around it. And one of them actually reached the castle. That's cool. Uh-oh. Dang it. They still got stuck. Okay, that's kind of frustrating. That time they all got by. I mean, in one sense, stupid enemies are kind of fun, but in another sense, they're not so much fun. It depends on how often it happens. That was fine. Let's watch the next batch. Got over just fine. So if they just occasionally get caught up, I guess that's going to happen whenever they're facing a corner or an edge, and their position is actually up a little bit higher than that. So the forward direction to them is this clear space, but the corner is still going to get caught. And I guess, yeah, now that I think about it, I see how that could happen. But it's pretty rare, because usually they come along the wall and they've got some forward momentum that carries them up to here before they turn diagonally. And then they just sort of nudge themselves along. So out of how many waves have we watched? Like 10 or 12 waves? I was about to say they only got caught once, and then they got caught again. Okay, I'm going to have to think about whether there's a simple solution for that particular situation. We could keep track of how long they've been stuck in a certain direction. Oh yeah, look at that. They all piled up. All right, fine. We can't call this fixed yet. All right. So when their speed is 0, or when we've just hit the wall, we know that we've hit the wall. We can keep track of our direction. And basically what I'm trying to figure out is some way to remember this direction's no good. Don't consider that direction. And then we'll add it up here as another case to just continue. But I'm struggling to figure out like when to clear that. I feel like we want to keep it around for a little while. So let's try enemy dot blocked direction and enemy dot blocked time. Okay. And how are we going to store the block direction? We could store it as as a rotation angle. But rotation angles are always tricky because around 0 and minus 180, they're discontinuities, right? Where it might look like a big difference between 0 and 359, even though it's really a tiny difference because those are angles. We could store it as a list of x and y, and let's see, check collisions. All right, here we go. After we check collisions, if our speed is still 0, that means we hit something. So if self.speed is equal to 0, then, oops, we hit something, this direction is blocked. Self.blocked dir equals dx dy, and self.blocked time equals time. Okay, so now we know that we hit something. The direction is the exact same as these directions. So we could say if self.blocked dir is equal to dx dy, and self.blocked, actually, let's not worry about unblocking it yet. Then continue. Okay. And down here, if we don't hit something, else if self.blocked dir and why is that indenting funny? Oh, because I haven't finished my statement. And let's see. I want to say if it's been a certain amount of time since it was blocked. So if time is greater than self.blocked time plus, I don't know, half a second, then self.blocked dir is equal to null again. Okay. So let's review. If we have a block direction and it's equal to dx dy, then don't consider that direction. Find the next best direction. And that gets set when we've moved forward, we've checked our collisions, and we find our speed is 0, which means we hit something, we block that direction at the current time. If our speed isn't 0, that means we successfully moved. So if we have a block there and spend more than half a second, we clear it. Yeah, that sounds good to me. Let's try it. All right, you guys, try a different direction. Hey, they did. They were stuck for a while, but then they got themselves unstuck. That was kind of cool. Let's see if it happens again. Next. There we go. Nice big batch. All right. I think we're probably good. So I'm going to call that done for now. I'm going to take off this red gradient, which is the distance to the castle. And yeah, we don't need that right now. You can always put it back. That is in grid. So, setup. Right now, we're using display 5 for the tile display. Instead, we're going to do outer.td equals a new. Anyway, before I change this, maybe I'll just comment it out. Yeah, we'll do outer.td equals new tile display. So that'll be an off-screen tile display. It'll work exactly the same, but we won't see it. Let's make sure that works. Nope, that does not work. All of my enemies are like, yeah, no, we're out of here. Forget this. They don't pay me enough. Right. I think, I want to, also, I can't see the walls anymore, and that's no good. I want to see the walls, I just don't want to see the gradient. So, let's go back to editing the grid. Terrible idea. Hey, it's morning. It's like 7 a.m. here. You can't expect me to think too clearly at 7 a.m. We'll go ahead and add the display, but we won't do the cell tinting thing. Which happens where? Distance to goal, set distance. I bet you this is where we do it. Nope. That's not where we do it. All right, where do we use cell tints? We don't. How can that be? Are we doing this somewhere else? No, it's got to be in grid. All right, what's going on? Oh, you know what? There is another trick I can do. Yeah, this is just using distance map. Prepare distance map. It's got to be in here. Set distance, set distance. It's just a list 2D. Ah, here it is, set cell tints. Why didn't that find it when I searched for it? Because I had match case turned on. Had I turned that off, I would have found it. Okay, cool. So yeah, we're just gonna keep the distance map, but don't set the cell tint. And now, hey, there we go, cool. Yeah, I also don't really love this strong checkerboard. That was handy during development, but we don't need it now. Oops, sorry, got a grid. So let's see if we can find where that's done, probably in setup, yeah. So we're clearing everything to 0, which is the first tile in tile shapes, which I bet, well, no, I don't need to look at it. But if we were to clear to null, then there would be no shape instead of a solid square shape for most of the grid. So let's try that. Yeah, there we go. Now the only thing missing is we used to have that nice sort of blue gritty background, and now we just have solid black. And that's because we took over display 5, which is normally the pixel display, for our tile display. So if we want to see the background, we're going to have to put that on a different layer. Draw background. Yeah, let's do this. So 5 is the tile layer. We'll use 6 as our graphics layer. Display mode pixel, GFX equals display 6. And then we can clear it and draw some lines. That would be good. Hey, there we go. Cool. We have our display back. And this is me, remember, I can move them around, I can attack the incoming tanks. Ah, come here. Yeah, cool. All right. So, time for an economy. Let's see, I think we'll keep track of this in main, which is what we have loaded already. Main is really quite short now, which is nice. The other place we could do it is in the castle. We ensure import castle, it sets everything up. Yeah, actually, I think I like that. Let's keep the main program short. And the castle health and money will be attributes of the castle. So we'll just put this in here somewhere. Castle.health equals 100. Castle dot. Actually, the castle's big. Normal enemies have health of. I don't know. That's not true. Normal enemies have 10 health. Castle having 100. Yeah, seems reasonable. And then we need some kind of currency. We'll call it cash. Yeah, we can start that at 0. Maybe we'll change it later. Who knows? Okay. After importing it, you'll have castle's direct reference to the castle sprite. Cool. So we can put some methods on this, such as castle that add cache, dcache, self.cache equals plus equals dcache. And then I'm going to need a function to draw the cache and the health somewhere. I think I'll just put them at the top of the screen for now. So castle dot draw stats, and we're going to do text dot row equals 25. Text dot color equals. Do we have a colors constant somewhere? Yeah, we do. It's under constants. Constants player color. Yeah, we can do this. And then text dot column equals. So let's see. We've got health and cache. We'll put the cache on the left, the health on the right, over by the castle. So I don't know. 4 print plus self.cache plus some spaces in case the cache has gone down, and then text dot. Here's a nicer way to do this. Text dot row equals 25 and column equals 4. Okay. And then we'll do something very similar. So much so that I might copy and paste, but the column in this case will be like 60. How do we want to label this? Castle condition, castle health, castle points. I guess we can figure that out later. Did we call it health? Yes, we did. But this is much too long to start in column 60. Let's start in column 50. See how that looks. Okay. So now we can say self.drawStats, and then we'll do the same thing for health. Even though usually we'll be deducting health, we'll just make them both the same. Okay, so we've add health and add cache methods. Also we have setup. Setup is a function, does a bunch of stuff, and then we can do self.draw. Actually, castle.draw stats. Okay. So now every time an enemy is destroyed, we want to add a little cache, and every time the castle is hit, we want to deduct a little health. How do we do that? Let's look at our enemies. Enemy hit, enemy take damage, enemy die. Well, here's where the enemy dies. We could do, we should give every enemy a cache value. Enemy.cache value equals 1 initially. When we have bigger, stronger enemies, we'll make them worth more. But here we can do castle.addCache, self.cache value. Self.cache value. Okay. And then take damage. Is this a thing that all sprites do? I don't think so. If others an enemy, return, otherwise other flash. And this is what's causing the castle and the player to flash when they're hit. but they're not actually taking any damage. I think I want to try and call take damage on anything that the enemy hits. The trouble is, okay, we'll do an ISA. If other is a player or other is a castle. Actually, we don't really need ISA. Well, but we'll go ahead and do it that way. Is a castle. Then other dot take damage. We're going to take out this flash call. Okay. So, both player and castle now need to take damage. And we don't have those, but player dot take damage, this function, self dot flash. And actually, this should have an amount. We'll come back to that. And let's edit castle. Oops. Yep. Thank you, MiniMicro, for helping me not throw out my changes. All right, now let's edit castle. And it needs to take damage. Castle dot take damage. This function. Self dot add health -1, and also self dot flash. All right. Reset run main. Can't set an indexed element of this type from current program line 13. What you talking about, MiniMicro? Sure, import castle. All right. Can't set an indexed element in this type. All right, let's reset. Import castle. Undefined identifier castle unknown in this context. I'm confused. What is it trying to tell us? Huh. Castle doesn't exist because it didn't successfully import. Undefined identifier castle unknown in this context. Why wouldn't you give me a line number on that? So strange. All right. Well, we're going to trial and error a little bit. I wonder if the problem is some sort of recursion in our imports, but that's what ensure import is supposed to prevent. And I don't see that constants, resources, or tower are likely to reference castle at all. So I think that's probably not it. Well, what did we add? We added this stuff. I wonder if you're all shouting at the screen right now because you know what the problem is. If you are, please shout a little louder because I'm still confused. That stuff didn't make any difference, so maybe it's this. I can't imagine why those wouldn't work. Those are very simple. Okay, what if we don't set up? Okay, come on. How can that be? Oh, I know how it can be. I didn't comment out this method. This was also added. Yeah, Okay, this is interesting. It is weird that it didn't give me a line number. It should have said undefined identifier on line 32. Because here I'm trying to assign to castle.drawStats, but if you haven't run the setup method yet, then we don't have castle as a thing. That's just not a thing yet. Right. So there's several ways we could fix this. We could move all these methods into the setup method. I don't love that because it just doesn't seem tidy. We could make a superclass for castle, put all the methods on that. Or we could define castle at file scope. Which we can safely do because Sprite is always available. Sprite's a built-in class in MiniMicro. So we could just do this and then in our setup do the rest of the setup. That's reasonable. And that way we can add methods to it at file initialization time, and it's all going to work fine. So, oops. Yeah. All right. Let's save that, reset, run main. Okay. Cache not found in map. I probably said cache where I meant self.cache somewhere. Self.cache. Anybody get the line number on that? Line 36. What? Cache not found in map? Oh, castle's still pending, is it? That's interesting. This would have to do with how ensure import interacts maybe with this trick of returning a class that happens to have the same name as the module. Let's take a quick look at ensure import. I've got the sysdisk contents open here. Import util. Let me embiggen this for you. Oh, come on. All right. So here's how ensure import works. If globals has index the module name. So if the module name is already in globals, then we just bail out. So we don't import things more than once. Then we immediately set globals of that module name to pending. And then we import it. And then we set globals module name to whatever that module returned. That ought to work. And it has worked up to now. So why isn't it working now? Oops. Here we go. Yeah, it's not going to have sprite display. No castle. All right, so that's when I tried to just import it. So something's still goofy. And it started when I moved this into the global space. So you know what? Fine. We're going to go with the alternative. This is more like how all the other classes work anyway. Make a castle class. And then castle will be an instance of that. Oops. And this way, if I ever want to make more than one castle, I guess I could. I'll move certain things out here just for kind of consistency with how we do it everywhere else. Or thinking if we did have more than one castle, what would they all have in common? They would all have the same image. They'd all have the same tint and bounding box. But they'd have different positions. I guess they'd all have the same scale too. And the same update method. Okay. Then we can define these things on the castle class. But we'll actually instantiate the castle instance here, and this should be outer.castle when the setup method is called. All right, reset, run main. Oh, come on, again with this? All right, oops. Oh, I just missed one. Okay, argument to new must be a map. I agree with that. New castle with a capital C. I bet some of you saw that when I typed it, and you were probably like, hey Joe, it's got to be capital castle, not lowercase castle. Or it makes no sense at all. Okay, cache not found in map still on line 37. Self.cache. Yeah, that's true, because I commented these out, which is probably the real problem all along, but that's okay. I'm actually liking this new approach. There's an editor bug that's not in the release version of MiniMicro, but in the 1.2.1 final candidate, which is why it's not released yet. But yeah, I like this better, having the separation between a class and the instance. I think that's nice and neat. So, all right, castle health 100. Our cache is getting wiped out by whatever this is. We've got some debug code in there that's showing the distance to the castle where the mouse is. Let's get rid of that. That's probably in main. Yep. Okay, take care of that. Okay, cool. We have, look at that. We're getting some cash from these guys. Cool. Our castle health was 100. Let's see if some of these tanks actually make it to the castle. Whoops. Undefined identifier player. Enemies line 90. Yeah, because it's actually player.player. Right? No. Player.lowercase player. So that's in enemies ms line 90. So edit enemies. Jump to line 90. Is a player.player. Castle, we don't have to do that because castle gets stuffed into the global namespace. All right. So let's make sure these guys can hit the player. I don't see the player flashing though. I should take this tower out while we're testing. Although it's awfully convenient for testing this feature, getting cash from the enemies. Yeah, I don't think they're damaging the player at all. That's a little worrisome. And they're not really making it to the castle. So two I'm going to do. I'm going to make the enemies a lot tougher. For now. And then, as for damaging the player, well, let's see if they damage the castle. They should certainly be able to make it to the castle alive at this point. Because they have 5 times as many hit points. Yeah, I don't see them damaging the castle either. There's a guy stuck on the wall. Still. Darn it. Yeah, they're not damaging the castle. Or the player. Enemy hit. The other's an enemy we just returned. Otherwise, we say take damage. Tell you what, let's find out if it's this if. It's causing the grief. We'll call take damage on anything. Since there are no other sprites on the board right now except for enemies. No, that's not true. There's a tower. But I don't think they'll hit the tower. Okay, there. That works. I need to add some spaces after the castle health if we're not doing that already. Let's see, can they make the player flash too? Yeah. So, let's fix the castle display first. Castle health display. Castle health, self-dust health, plus some spaces. Okay. And then, let's figure out what's going on with this if test. We'll do that by saying if it's a player or a castle, tell it to take damage. Otherwise, globals.wtf equals other print. Let's preprint WTF and exit. So run. Oops. Reset run main. Okay. So, it's hitting me, and what is me? I'm something with an is-a that's a little hard to define. WTF is-a. Let's see, it has no image. What about my own image? Let's view WTF.image. Okay, so it's definitely the player. So WTF is a player.player. No. WTF equals player.player. Yes, it does. Oh, that's interesting. I thought that is-a would return true if you asked if something is-a itself, but no, it's checking whether it's an instance of that type. So we could do ref equals WTF player. What? Oh yeah, player.player. Or we could just use equals. The reason I'm hesitating on equals is when it's not something. Like if we say player.player equal to castle, it actually walks down into the map and starts comparing element by element, which could be kind of expensive. But it's going to bail out as soon as it encounters anything that's different, which will happen pretty quickly. So it's probably fine. So let's edit enemies and go down to where we're dealing that damage. Yeah, so we can just say if it equals player or it equals castle, then take damage. Where's our reset run main? Okay. Yeah, okay, cool. So player's flashing, castle's taking damage, it's correctly showing the damage. I'm digging that. We could move this over one more character just to make that a little bit neater. This is looking good here. Wade in and try to kill some of these guys. Boy, with 50 hit points, I tell you what, they are not easy to kill. Good. I got myself stuck in the wall. Okay. So we'll probably put their hit points back. Although 10 might be not quite enough. Let's go 15. That should be enough to get to the castle. Ooh. This is next 20 out of range. Grid.ms. Oh, that happened when I went off the top of the screen up here. Let's reproduce that. Drink. Yep. And then all those up arrows that were buffered applied to work through my command history. Okay. Let's check our stack trace. See how we got here. So the error happened in grid.ms line 84, but that was called from player ms line 45. Let's start by looking at grid though. Line 84. If while BB and while BB overlaps BB. I think the problem is actually here on line 83, trying to get the cell balance of the column and row. We need to check if that's in range. Do we have a function for that? Nope. Okay. So, we have rows and columns though. Where were we? Yeah. If C is less than 0 or C is greater than or equal to columns, then continue. And if R is less than 0 or R is greater than or equal to rows, then continue. Unless we wanted to make it behave as if it's always hitting. But nah. If we want to put walls around the arena, we'll just put walls around the arena. So let's leave it like that. Reset run main, try to go off the top. Yeah, now it's fine with it. Cool. Okay, none of those invaders made it to the castle. Next wave. Cool. Still didn't make it to the castle. My defenses are a little strong. But, you know, ultimately the idea is rather than wave after wave nonstop, look at this guy still getting stuck. And once it happens, they kind of pile up. That's frustrating. Anyway, but the idea is that instead of having wave after wave nonstop, there's going to be a few, maybe we call them mini waves or sub waves of invaders that come in. And then there's a break where you get as much time as you like to work on your base. And when you say you're ready, then you click a button and start the next wave. And the invaders are going to get stronger and stronger and more numerous, so that if you don't keep upgrading your defenses, you'll quickly get overwhelmed. What am I going to do about these guys still getting stuck? And how could it even happen? Seems like if there's an invader here trying to go this way, that direction is going to be marked as blocked, and it's going to have to try a different direction, which would probably be diagonal up this way. Yeah, right there. How's this guy stuck? Alright, I want to fix this. This is going to bug me. I'm digging the rest of the game so far. I don't think we're going to get to actually spending your money today, unfortunately, but we'll save that for next time. But I want to get this fixed. So to do that, I want to get rid of this tower, and then I'm going to manually place an enemy at just the right spot to get stuck, and then we can really dig in and debug it. So let's edit main, see where we're setting up our tower. Yep, here's where we put in our tower. Get rid of that. And then for our enemies setup, spawn. Okay, I'm going to change the spawn method right here. First, we're going to just spawn one. And then second, I'm going to fix the X and Y. So let's comment out these lines. And we'll do enemy.x equals, I don't know, 200. And then I need to figure out the right Y. Let's see, if I put my mouse right here, this is where I want the enemy to spawn. And that's X of 298, we'll call it 300, and a Y of 48. So 348. Okay. And let's see if that does it. Nope, he went right around. That's probably because he was facing north initially. We want him to face due east. So where's that set? Rotation equals 90. Okay, well we'll put it in our heck down here in the spawn method. Enemy.rotation equals 0. Got around it, no problem. This could be tricky. And it could get a little tedious, huh? 44. Got around it perfectly. Oh, there we go. Okay. Zoom, look at that. Right, because it's only the initial spawn that's a single enemy. Okay, well, probably the first one is this one. Let's say enemies 0.scale equals 2. Whoops. Enemies 0.scale equals 2. No, it's not that one. Huh. All right. I really want to get this guy. How am I going to find that? I could write a little loop. E in enemies. Actually, I want I. First of all, M equals enemies. All right, for I in m.indexes. If math.util.distance from m of I to the mouse less than 4, then print I and 4. Okay, it's 6. So E equals m of 6, and now I can do E.tint equals color dot white. Yeah, that's the guy. Okay, so here's what we've got on this enemy. It's got its position, its rotation is 0, its speed is 1, it has a block direction 30-30 and a block time. So it was trying to go, wait a minute, 30-30. It's trying to go that way. Oh, you know, I think maybe the problem is just that we need multiple block directions. Let's try calling update on that guy. All right, its direction is unblocked. Blocked 3030, blocked null. I mean, it's taking me more than half a second probably to do this. So that's why it's unblocking. But when it blocks, it's always 3030. And 3030 is up and to the right. So it's trying to go this way, but it's still blocked. Can't do it. And what I want is for it to turn and go this way. In fact, hang on. How's it even considering 3030? That's a diagonal direction, and its speed is less than 2. So that's a puzzle. Let's look at enemies. If speed is less than 2, and neither dx nor dy is 0, then we continue. So it should never be able to consider 3030. Is there some way that its speed could be not 2? Enemy.debug is false. We're going to have a debug flag, and we're going to say if self.debug, then print update speed. We don't need update, just speed. Block dir. Self.blocked. There, it should be self.speed. What else? Yeah, that's enough for before the loop, and then after the loop. Best delta. Okay. So wait till they pile up. Then we'll do a similar trick to what we did before. Come on, enemies. Don't be shy. There we go. Okay, there's a guy who's stuck. We'll do this loop to find the one close to the mouse. Wow, it's way up in my command history. Here it is. Oh yeah. M equals enemies dot enemies. Oh, none of them? I don't believe you. One of them is definitely close to the mouse. Okay, it's number 6 again. All right, so E equals enemies 6. Let's clear text a little bit. Okay, now I'm going to do e.debug equals true. E.update. After all that, I made a typo. Do it again. Self.best delta blocked with an E. Dir. Okay. I'd like this better if it was like this. Okay. Let's run again. Okay. Oh, it's number 7 this time. So equals enemy 7. Set debug to true on that. Do an update. Okay. So its speed is 1. Its block dir is 3030. And its best delta is 30, 0. So at this point, it's thinking, go straight to the right. Okay, well that fits what we're seeing. It's always trying to go straight to the right. Because where it is, it's actually this cell. And it thinks that's fine. And that direction's not blocked. So yeah, this all boils down to we need to block more than one direction at a time. What a pain in the tuchus. But I think we can fix this without too much trouble. So block dir is going to be a list of directions that are blocked. It's interesting. We have them, if it can't find a direction to move at all, we have it just die. I don't know if that's going to be a problem when I do this. But it might. Let's find out. So if, let's see. List of x, dx, dy block directions, which we're going to have to set in the setup. Let's see. Do we have a setup method? Do we have like an init? Not really. We have a spawn. I'm going to give it an init method. enemy.init equals function self.block dir equals list, just so we can always count on it being a list. And now we're going to say a self.blockdir.contains dx dy, then continue. And then when we find ourselves blocked, we can say, oh, you know what? That could be a map instead of a list. So a set. Okay. That way we can just say push self.blockdir.push dxy dy, and then when we reset it, just clear the map. Do maps have a clear method? No, that's not a thing. That's a C# thing, not a MiniScript thing. Yeah, so we'll just set it to an empty thing. So now, let's just try it. Who knows? Maybe it'll work. I'm feeling lucky. Next wave. Come on, enemies. There you go. Still getting stuck. That bugger. Let's see what he's got. We're going to do our trick as before. It's number 7. Pretty print that guy. Okay. What? That's not a map. That's a simple list. So I missed something. Block dir equals dx dy. Well, first of all, I meant to say if it contains dx dy. Did I not save my changes? I think I didn't save my changes. That's embarrassing. Okay, no problem. If we hit something, we're going to push dx dy. When we reset it to here. We give ourselves an init method. That does self.block dir equals empty map. And then when we create an enemy and spawn, we'll be sure to call init save it this time. Reset. Cancel element of null on line 127. Oh yeah, the init method needs to return self. That's how we do that. So that we can assign it to things. Contains not found in map. Oh, I guess we need map utils. Still not found in map? Really? Oh yeah, we can just use has index in this case. That's true. Lists need contains, maps don't. That was the wrong file anyway, but edit enemies. Although let's find out if I import map util. It still doesn't have contains because you don't need it. It would do the same thing as has index. So edit enemies. Do I? Yeah. No real changes. Okay. Has index. Reset run main. Okay. That guy got around just fine. Whole bunch of them. Oh, come on. All right. We'll get to the bottom of this. Who knew this would be the session mostly dedicated to getting unstuck from corners? Oh yeah, gotta actually put my mouse there if I want this to work. Number 2. Okay, so it's blocked in only one direction. Okay, so this is interesting. I'm calling this update pretty fast, and every time it's blocked in the diagonal direction, and it's choosing this straight to the right direction, and it's not adding that straight to the right direction to our map. So I have many questions. Oh my gosh. This is such a dumb mistake. I wonder how many of you have been shouting at me for the last half hour that I'm storing the wrong dx and dy. I'm storing just whatever happens to be the last dx and dy that we loop through, which is always 30/30. It's not the best dx and best dy. That would be best delta. Yeah, that would be best delta. That's what I meant to do. Oh my gosh, that's embarrassing. Well, I hope this is encouraging to anyone else who has ever made a dumb mistake and wasted most of an hour trying to track it down. It's always in the things that you aren't thinking about. Some assumption you're making or someplace that you don't have your attention. All right, reset, run main. And now, that's interesting. It just went pop. It invoked that thing where all the directions were considered blocked. And it just disappears. But I think in this case, it might be sufficient to only store one block direction, which we can do for now just like this. And if this works, we'll go back to the simpler code where there's no map. Beg your pardon, line 60. Oh yeah. Map that to 1. Next. Yeah, look at that. Now they're fine. Oh, that guy's still stuck though. They look a little more agitated than when they got stuck before, but they're still getting stuck. Okay. That's interesting. Even though they could turn to the north and get free. Okay. So, edit. All right, so maybe apart from the dumb mistake, it was still in the right direction. Edit enemies. All right. So the problem was when I was pushing best delta is that we were getting into this case. And just dying. And that would happen if all the directions were blocked. Yeah, because if any direction's not blocked, well, any orthogonal direction is not blocked. It's not going to consider the diagonal directions if its speed is less than 2, and that's okay. The question is, why was it never considering just going north? That ought to work. Let's see, in direction dx dy just equals just. All right, so we're going to get this to the failing case again. It's hard to think about things when you're thinking hard about other things, isn't it? All right, line 42 of self.debug, which of course is what programming is all about. Can't move, woe is me. Yeah, okay, but next, oh, they're all gonna do that. Yeah, that's not super helpful. Take that bit out. Right, we still need to do something. But actually, this is good. Enemies 0. e.debug equals true. Update. Okay. So, check out its block directions. It's blocked at 30, 30, which is up and to the right. It's blocked at 0, 30, which is straight up. Is it really? That's surprising. And then negative 30, 0 is also blocked. That's to the left. Come on. How are those blocked? Let's clear its block directions. e.blocked dir equals empty and do an update. Okay. So there we have distances, and our best delta is 0, 30. I should print E, pretty print E right after calling update. Okay. So its best delta is minus 30, 0. Its rotation is 10. Okay. In that case, its best delta was 0, 30, which is up. But it reckons it's blocked. So I think maybe the problem is that as it rotates, because its bounding box is square, it's clipping. And yeah, no matter what direction it tries to go, it's got to rotate to get there. And that causes its bounding box to clip into the wall. And this is kind of inherent in the nature of squares rotating around other squares. So it's not that it couldn't find a direction to go, it's that it can't rotate to face that direction. And so it gets frustrated and goes pop. Or if we take out the popping, it gets frustrated and just stays there. Yeah, that would happen. We'll consider collisions with anything that is currently in front of the sprite. So if you draw an imaginary line like this, we'll consider stuff over here, which does include this. So, golly, it's been more than an hour already. I've got other stuff I gotta do, and if you're still with me, wow, I admire your stamina. And I thank you for your support, but I think I'm gonna call it a day, and I'll leave some notes in my progress log about where we left off and what the problem is, and then we'll revisit it next time. Because I really want to get these guys moving smoothly. So it might mean switching to a different style of collision detection where we imagine a circle around the enemy. That's not something that bounding box can do built in, but we could do our own math and figure it out. Or something else. I don't know. I don't know at the moment what the right solution is. If you have any ideas, hop on a Discord or leave a comment below and let me know what you think. And probably next week, we'll come back to this and we'll see if we can find a good solution. Till next time, happy coding.